So for the first one, to find the minimum and maximum clearance, what we'll do is we'll start out with the pin in the hole. And we'll find the minimum size of the pin and the maximum size of the pin. So for the pin over here, what's the minimum size? 0.721. What's the maximum size? 729. For the hole, what's the minimum size? 731 and maximum 739. Now this is a clearance fit, which means the pin has to have extra space to fit into the hole. The hole has to be bigger than the pin. So we're going to find minimum and maximum clearance here. Minimum clearance is going to be when the pin is at its largest and the hole is at its smallest. What's the difference there? 0.002 inches, 2/1000ths of an inch. It's enough that it should slide in, but there's any imperfections in the surface, it's going to have some hang-ups. Maximum clearance is going to be found when the pin is small and the hole is large. What's that difference? 18/1000ths. Anybody have both of those? Everybody see how to get to them now? Anybody have questions? For a gauge block buildup, remember you have to start with the smallest digit. So if we're looking at for inches here, if you're looking in your packet, it's page 111. Oops, not 111. Where are you? Page 126. Yeah. Or 46. Sorry, 146. We have to do the 10,000ths first. So there's 4 10,000ths there. So we find the block that has the 4 10,000ths. That is the 0.1004. So that's the first block in our buildup. So we have to subtract that off here. This is 0.872.2. It's the second step of our gauge block buildup that's a little difficult. In the second step, we have to accomplish 2 things at once. We have to get rid of this digit. Then we have to make this digit into either a 0 or a 5. Well, 7 is bigger than a 5, right? Which means we're going to take it to a 5. So to get rid of an 8, we're going to have an 8 there. Take that to a 5, it's going to take a 2. So I don't care which one we're going to use, those 2 digits have to be 2 and 8. So if we look in there, we find that there is a 0.128. So that is the second block in our buildup, 0.128 inches. So we subtract there. We're at 2.15. So now then we've got to wipe out everything after the decimal point. And we will see, as we look, there is a 0.150, 150 thousandths. So that is our fourth gauge block, 0.150. Which leaves us with 2. So then we just take the 2-inch gauge block. So that is the buildup for that. Anybody get that? 123 here. So 123 wouldn't wipe out your 8 though. I suppose you could do a 123 and take that to a 5 and then do a 155 or something like that. Okay.
I got a question.
That would work. You just have more blocks that you need.
Yeah, that's it.
Yeah.
So if it's always over a 5, you know it's gonna.
In that second step, yes. If this is larger than a 5, you're gonna try to take it to a 5. Yep. Because your gauge blocks only go up to the 149. They don't even do 150. So yeah, first thing you gotta do is if there's any 10,000ths, you take care of them. If there are no 10,000ths, then you jump into the thousandths. And as you're getting, always for inches, as you're getting rid of the thousandths, you have to get that hundredths digit either to
I
0 or
was just
5.
wondering if, without even having to look at the chart, you
Yeah.
know right away.
Yeah, you know. Yep. Yeah, I mean, I'm at a point where I can do a gauge block buildup without the chart, but it's not. It doesn't take that long to get used to it. You just have to know what the large maximum size is in each series. Okay. Well, sounds like we've got that down. So today we're going to keep going with some other conversions. We've talked about we've kind of exhausted our lengths. And lengths actually give us a few different things. Lengths give us not only lengths, but they also give us area, because area is just found by multiplying two lengths together. And they give us volume. And volume is just found by multiplying three lengths together, or an area times a height. Well, when we converted, let's say we had 72 inches converted into feet. Let's just review this a little bit quick. 72 inches becomes how many feet? 6 feet. What if I'm going the other way? What if I have 5 square feet going into square inches? Don't say 60. I'll give you a hint. Why is it not 60? Why isn't it not 5 times 12? It's square feet and square inches. How many square inches are in a square foot? 144. It's 12 by 12, or 144. So 5 times 144 would be 720 square inches. What if I have 567 cubic feet going into cubic yards? How many feet are in a yard? 3. It's cubed though, so it's going to be 3 by 3 by 3. 27. Multiply or divide by 27? Well, I just wrote divide, so probably divide. Right? How do we know it's divide though? Because from feet to yards, yards are bigger than feet. The unit's getting bigger, the number must get smaller. So it should be 21 cubic yards. How about cubic feet into cubic inches? First of all, multiply or divide? From inches are getting smaller, so the number gets larger, so we're going to multiply. Inches and feet, the relationship is 12 inches in a foot, right? So how many in a cubic foot? 12 by 12 by 12, 1,728. So 3,456. In the metric system, our conversions are easier. We just have to keep track of the powers on our units if we have any. So let's say we have 370 millimeters going into centimeters. What's that going to become? Just need your little conversion chart, right? Kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters. So from millimeters to centimeters, we're moving one spot to the left on the chart, right? So what do we do with the number? Move one spot to the left with the decimal point. That's 37 centimeters. What if I have 4.2 meters squared going into centimeters squared? Yes. 2 spots to the right on the chart, but it's squared, so we got to double it. So the decimal point goes 4 spots to the right. So we got to fill in zeros. That is 42,000 centimeters squared. 2,800 millimeters cubed into centimeters cubed.
To the left.
Yeah, you get from millimeters to centimeters, it's one spot to the left. But it's cubed, so we triple it. So 2.8. So what if we have 0.0008 meters squared to millimeters squared? Meters to millimeters is 1, 2, 3 to the right. It's squared, so we got to double it. 1, 2, 3, 4, 5, 6. It ends up being 800 millimeters squared. From meters cubed to centimeters cubed. It's 2 spots to the right on the chart. But it's cubed, so we have to triple it. So it's 6 spots. It's going to be 70 centimeters cubed. What do you think? Okay. So these cubed units, like meters cubed, centimeters cubed, inches cubed, feet cubed, cubic feet, those are units of volume. And remember, volume is an area of a base times the height. Of course, our only exception was a sphere that doesn't have a base. But we saw even for cones and pyramids, it's still that area of the base times the height, then we adjust it for the fact that it goes to a point instead of straight through. Our new units that we're going to explore today are units of capacity. The difference between capacity and volume is extremely subtle. In effect, what they measure is really exactly the same thing. It's just how we go about measuring. Capacity is just standard size containers that are used to measure how much is in an object. Volume is figuring out how much is in an object by taking measurements off of it. So you're really finding the same thing, just approaching it in a different way. In our standard units of capacity, we'll start out with a gallon. And a gallon actually just came from the normal size of a man's hat. I mean, I'm not talking like a cowboy hat. I'm talking like a dress hat like they used to wear in Europe and back in the old days. Not necessarily a derby hat, but similar to that. The smaller hat. What's that? Not necessarily military, just their standard dress hat that they would wear when they were out on the town. Now you've heard the phrase, a 10-gallon hat. That doesn't mean the hat held 10 gallons. It just means a really big hat. So it's just kind of a figure of speech. But smaller than a gallon. What's our next smaller unit? A quart. How many quarts are in a gallon? 4. And to remember that, the word quart actually came from it was a quarter gallon. And they shortened the phrase quarter gallon just to a quart. They started calling it a quarter, then a quart, and that's where it ended up. Smaller than a quart, what do we have? Pint. How many pints are in a quart? 2. Like we talked about with measurement, how we had, feet, inches, and all those, and they were never used together, but it was years later that they adjusted the size of them to make them fit. That has happened with the pint and the quart. The pint has not really been adjusted, but it was the quart and the gallon that were actually adjusted to make them fit. The pint, was defined to be, the pint was a standard size cup that you go in and order a pint of beer, a pint of ale, or whatever. It was a standard size cup, basically a jar, pretty much, that was what liquor was served in. And it was also used for preserving foods and stuff like that. Smaller than a pint, we have cup. There are 2 cups and a pint. A cup literally comes from your cupped hand. And it's for powders, sugars, flours. It's not for measuring. It was never intended for measuring liquid. Now that we have measuring cups, we actually can measure liquid with it, but it actually was a heaping cupped hand. I mean, not flat or anything, so I obviously couldn't do it with liquid. But it was, and I mean, I have a couple of friends who are caterers. They never use a measuring cup for a cup. It's always their hand, and I've double checked them a couple times, and they are dead on with it. And it's pretty close. That's another one that hasn't changed a whole lot. That they've kept standard. It's the other sizes they've adjusted to make them fit together. A little bit of a word of warning, depending on what type font you're using. Quart is abbreviated QT, pint is abbreviated PT. You can see Q's and P's are pretty close, so they're just the mirror image of each other. So if you have any problems with flipping letters, be careful of that one. Real easy to look at quart and see pint. Smaller than a cup, what do we have? Anybody? Fluid ounces we have. How many fluid ounces are in a cup? 8 fluid ounces in a cup. A fluid ounce came from the size, the amount of space taken up by 1 ounce of water. So a fluid ounce is equal to, is equated from water. Smaller than a fluid ounce. 1 fluid ounce contains 2 tablespoons. Smaller than a tablespoon. Teaspoon. How many teaspoons are in a tablespoon? There are 3. So there's 3 teaspoons in a tablespoon. A little bit of a warning there, by the way. Tablespoon can be abbreviated a small TBSP or a capital TBSP. Both of those are pretty clear, but it can also be abbreviated with a capital TSP or just a capital T. Whereas teaspoon is abbreviated either small TSP or just a small t. So you can see a lot of times the only difference in the abbreviation between tablespoon and teaspoon is a capital T. Most of your modern cookbooks, by the way, just use capital T and little t. So be very careful with that. You don't have to write these next ones down. You'll never be tested on them. But there are units smaller than a teaspoon. Anybody know what they are? A teaspoon contains 2 dashes. A dash is literally the old spice shaker. It's kind of like a salt shaker, only bigger. And a dash, you just tipped it and shook it once and tipped it back up. That was a dash. Smaller than a dash? Any guesses? 3 pinches. A pinch was literally you reached out your fingers, pinched it together, and what was between your fingers is what a pinch was. Smaller than a pinch? What do you have? Anybody know what's smaller than a pinch? Pinch contains 2 smidgens. Pinch is the one, or the smidgen is the one that always kind of got to me a little bit. Is that you stick your finger in the powder, and what sticks to your finger, you flick it off. Actually, at one time, almost all bakers were male. Yeah. But yeah, the baker with sweaty fingers has really big smidgens. Just think about that for a second. So anyway, there are other units bigger than a gallon. Does anybody know what a bushel is? Bushel is 8 gallons. How about a peck? a peck. Peter Piper picked a peck of pickled peppers.
I never knew that.
Yeah, but then they ask how many that is.
Yeah. If you ever buy strawberries, the strawberry patch, they'll actually have the 1 peck and 2 peck trays that you can buy. 1 peck is 2 gallons. By the way, they're 1 peck trays. They don't measure out 2 gallons of strawberries and put them in there. They just got a standard size tray and they stack it up till it looks about right. I've checked them and they're always short. But how about a barrel? What's that? Oh yeah. They said, oh, that's just the size. The peck. They don't realize that. Most of them don't realize that peck is actually a measuring unit. They just think it's the name of their tray. A barrel. Anybody know a barrel? Most classes say 55. 55 is a drum. 31.5. Quarter barrel is 7 7/8 gallons. Okay, well now here's the thing. We said capacity and volume measure approximately the same thing, and they do. Problem is the conversion between them is really ugly. 1 gallon contains approximately, notice I'm not doing the straight equal signs, I'm doing kind of wavy, approximately 231 cubic inches. Now, picture a cubic foot. Now picture a 5-gallon bucket. Most of us have worked with 5-gallon buckets. Do you think a 5-gallon bucket is more than 1 cubic foot or less than 1 cubic foot? Most people would say more because it's definitely taller than a foot and it seems to be about a foot across. But it's rounded, which means the corners are cut off. And also on the bottom, it's only about 9 inches across on bottom. 1 cubic foot is about 7.48 gallons. Depending, some textbooks listed as 7.5. They just rounded off there, which is close enough. So if you think about that, a 5-gallon bucket's only about 2/3 of a gallon, or only about 2/3 of a cubic foot. So those equivalencies are a little tough to deal with. So let's say we have a cylindrical tank that has 4-foot radius, or 4-foot diameter and 6-foot length. How many gallons of fuel are in that tank? Well, we're going to find our volume here. This radius is how much? 2 feet. So the area of our base pi times 2 squared, which will give us 12.56 square feet. So our volume, 12.56 square feet times 6 feet, is 75.36 cubic feet. Sound about right? So our capacity put the 75.36 over 1 cubic foot, 7.48 gallons. $563.69 gallons. So it's over a 560-gallon tank. What do you think? Oh, let's look at metric. For metric capacity, our standard unit is the liter. Just like with length, if we want something smaller or larger, significantly, we use prefixes. So now I was always taught, by the way, you abbreviate a liter with a capital L. The reason for that was, I mean, I learned the metric system in the late 80s. At that time, there weren't the vast variety of type fonts you have now. In most type fonts, a small L and a 1 were really tough to tell apart. In fact, on some of your older mechanical typewriters, you didn't even have a 1 key. You used a small L in place of a 1. So when you look at something like that, is that 51 or is that 5 liters? Well, if you use a capital, it's pretty clear that's 5 liters. And when you're doing handwriting, I would suggest using a capital L just to make sure it's clear. You don't have to. With modern type fonts now, and a lot of your type fonts, there is a distinguishable difference between a 1 and a small L. So it is now acceptable to use a small L for liters. It's just I'm always going to use a capital L because that's what I'm used to. So smaller than a liter, we have a deciliter, which is a tenth of a liter. Centiliter is a hundredth of a liter. And milliliter is a thousandth of a liter. Larger, decaliter is 10 liters. Hectoliter is 100 liters. And kiloliter is 1,000 liters. Centiliter, yeah, CL. Just like in our other units, what gets used here mostly is the main unit and the milli and the kilo. The other units in the middle kind of fall out. In fact, the only application I've ever seen of any of these others, you see deciliter gets used used exclusively in medical blood testing and urine testing. Like, let's say they test your blood glucose and it comes back at an 89. That is 89 milligrams of blood glucose per deciliter of blood. Or your cholesterol coming back is a 140, whatever. That's 140 milligrams of triglycerides per deciliter of blood. So deciliters do get used in medical blood testing. But other than that, it is pretty much liters and milliliters. Even kiloliters don't get used much. A liter is just a little bit smaller than a little bit larger than a quart. So a kiloliter is like 270 gallons. So that's pretty large and not terribly useful.
So it's deciliter, hectoliter, and kiloliter.
Milliliter, liter, and kiloliter that you use the most.
No.
Oh, here? Yeah, that's deciliter, hectoliter, and kiloliter. You're right. Our conversions are the same as always. Come on. If we have 0.09 liters, I want to convert that into milliliters. Liters to milliliters is 3 spots to the right, so I move my decimal point 3 spots to the right. I get 90 milliliters. So just like any other unit in the metric system, we're moving the decimal point. That's all we're doing. Now, here's where the metric system really shows its strength. As we saw with the standard system, not only were the units within each type of measurement not ever intended to be used together. I mean, inches and feet were never intended to be used together. Gallons and cups and pints were never intended to be used together. We had to adjust them to make them have a conversion. And those conversions turned out to be very ugly. But there was definitely never any relationship between length and capacity. I mean, from one type of measure to another. In the metric system, they actually thought ahead on that. So when they defined the size of these items, they made sure they linked up. 1 milliliter is defined to be the volume of a box. A cube is 1 centimeter by 1 centimeter by 1 centimeter. In other words, 1 milliliter is defined to be 1 cubic centimeter. For that reason, it is extremely simple to find volumes, capacities based from volumes. For example, let's say you've got a car, a 6-cylinder car. And if you look at your car, you got the bore of the cylinder and the stroke. Okay, so let's say, oh, what do I have to have here? Oh, let's say that this has a bore of 12 centimeters and a stroke of 6 centimeters. The displacement of this motor is literally the amount of air that is displaced when the piston moves up and down. So you think of the head of the piston, which is a circle, as the base, and it moves through a length of the stroke, or the height becomes the stroke. So the volume of that cylinder, the area of that base, is going to be pi times what squared? 6 squared, perfect. So 3.14 times 6 squared, 113.04. So we're going to get a volume, is that 113.04. Now that was centimeters cubed. So centimeters cubed times our stroke length of 6 centimeters. No, centimeters squared, I should say.
Yeah.
Times our stroke length of 6 centimeters. So 678.24. And this is in centimeters cubed now. That's per cylinder. Now there's 6 cylinders, so I'm going to multiply that by 6. $4,069.44. That's centimeters cubed. So if I have 4069.44 centimeters cubed, how many milliliters is that?
Same.
Exactly the same. 4,069.44. How many liters is that? From milliliters to liters, you're going 3 spots to the left. So that's a 4.069 liter. 4.1 liter, they'd probably rate it as. So you can see that relationship in the metric system make things really simple. When we talk about mass and weight tomorrow, there's even more connections that make things nice and simple for us. So in the big book, on page 253, exercise 8-9 to the odds, page 254. Exercise 8-10, page 274. Exercise 9-11, and page 274 through 275. Exercise 9-12. Those should go pretty quickly.